Hello everyone, welcome to the lecture of IC engine and fuel lubricants. Today the lecture will be on engine cooling. So, this is the contents for the today's lecture. Purpose of cooling system, in fact engine cooling system, modes of heat transfer and different cooling systems or types of cooling systems. So, first of all you should know what is the engine cooling system. We all know that the engine, what is engine? Engine gives you the power output, and what it consume? It consumes the fuel energy. So, when the fuel burnt, fuel does not burn alone, it requires some air as per the composition of the fuel. So, when the air fuel mixture burn, that process called combustion. So, when combustion occur, so they what happens, a huge amount of energy is released, that is fuel energy or chemical energy. So, that energy, as per first law of thermodynamics, what happens, that this amount of fuel energy is partially converted into the useful work, because some amount of the fuel energy, which is heat energy, is exhaust out through the exhaust with the combustion products or exhaust gases, and some amount is lost in the cooling of the engine. So, why the cooling is required? So, if you approximate it as that 1/3 of the chemical energy of the fuel is removed by the engine cooling system. This is only the approximation. 1/3 means 30 to 35% is lost, and 30 to 35% is lost in the exhaust with the exhaust flue gases. So, remaining approximately 30 to 35% is only convertible into the useful work, which is known as the its thermal efficiency, maybe the brake thermal efficiency also. So, engine is heated. Why engine is heated? So, engine is heated because of the combustion of air fuel mixture. And you know that engine is made of different components like cylinder, piston, cylinder block, piston head, piston rings, oil rings, connecting what, a number of components are there in the engine, intake manifold, exhaust valve, inlet valve. So, a number of components are there in engine, like bearings for shock absorption purpose. So, these all are made of different material, and each material is having its metallurgical limit or melting point. So, engine is heated because of the combustion of air and fuel mixture. You know that when combustion occurs, the temperature rises by burnt gases may be of the order of 2000 to 2500 degrees, depending upon the type of the engine, size of the engine. So, it varies, but you can approximate as it is a huge amount of temperature is generated, 2000 to 2500 degree Celsius. So, cylinder wall temperature, it is assumed by the designer that it should not be more than 200 to 260 degree Celsius, because of the metallurgical limits of the components, different components of the engine, like I have discussed piston, cylinder block, piston rings, bearings, etc. So, temperature higher than this cause the lubricating oil film to break down and lose its lubricating properties. Also, this temperature rise affects in two ways. First, it disturbs the metallurgical limits of the engine components, and second one, it break the lubricating oil films, which is required to smooth the engine operation, like in bearings, in different components, in different components of the engine, we need some lubrication. So, this lubricating film should be sustained at the operating temperature of the engine. And if what happen if the temperature cannot be controlled, you are not able to control that temperature. So, what will happen? This lubricating oil film will get evaporated, or other metallurgical limits will be achieved, and the different components may get damaged, may get failured because of this high temperature. So, I have discussed that 1/3 of heat approximately has to be removed from the engine. So, cooling system should be such that it begins to function when engine reaches its operating temperature. It means the cooling system cools the engine rapidly when it is hot, and slowly or not at all when the engine is cooled or warming up. It means the engine cooling system should be such that when it is required to cool, it cool, and if it is at engine is at warm up condition, it does not cool that engine. Otherwise, what will happen? The engine will not be started. So, engine cooling system is one of the necessary thing that is present in the internal combustion engine to reduce the temperature of the components inside the engine. It also helps to reduce the wear out of the component and provide smooth functioning and long life of the components. So, why we need cooling system of an engine? Heat generated inside the cylinder during combustion and power stroke due to the burning of fuel air mixture rises the temperature and pressure inside the cylinder. Second one, temperature of burning gases in the engine cylinder reaches very high. So, you have to control that, so that the melting point is not achieved by the engine component. So, this heat is to be dissipated, is required to be dissipated, and due to high temperature and overheating, distortion of the engine component takes place, like piston breakdown and pitting of water jackets. You can see this you can see this type of failure occurs if you are not able to control the failure of the engine, or you are not able to control the cooling effectively. So, this is the type of breakdowns are occur, piston breakdown and pitting of water jacket. Water jackets are those parts in which the water is flowing for cooling purposes, surrounded by from the cylinder sides. So, you can see here this is the pitting type, pitting of the piston, because the melting point is achieved, we are not able to control the cooling rate of the engine. So, this type of fitting is not desirable. Also, the pitting of water jacket means like this is your cylinder, then this is your inlet valve, exhaust valve, then this type of pockets are provided around the cylinder through which either air or the water is flown and the cooling is controlled, because we have to cool the surface of the cylinder in the range of the metallurgical limit, which is 200 to 260 degree Celsius. If you are not cooling, or if you are not effectively cooling, then this type of problems will be arises, and these are not desirable. And this, if it occurs continuously, engine may get seize. Now, the modes of heat transfer. You all know that you are in B.Tech third year. So, you all know that what is heat transfer? Heat transfer occur because of the temperature difference. So, the heat energy which flow because of the temperature difference, it required some mode, transportation mode, that these modes are three: conduction, you all know that what is conduction, convection and radiation. So, first of all, conduction. For first one dimensional flow, it is governed by the Fourier law. So, heat transfer rate is equal to minus Ka dt over dx, where K is thermal conductivity of the material through which the heat is transferred, dt over dx is known as thermal gradient, A is equal to the area through which the heat will be conducted. Like I am taking a wall, plain wall, like this is a plain wall. Let here this heat is transferred. So, let this is thickness dx in the wall, this is the q amount of heat which is transferred, and the material of this material is having thermal conductivity K, and this cross sectional area is A. This is the cross sectional area, which is the area through which the conduction occurs. So, for this elemental ring, elemental area, the heat transfer is equal to minus K A into dt over dx. dt is the temperature difference between this dx distance. So, dt is this. So, dt is this minus K A dt over dx. So, this is the mode of heat transfer in which medium is solid. So, solid medium is there for the conduction purpose. So, in detail you can go in the syllabus of the heat transfer, different types of heat transfers and how they are formulated, all these things. So, now come to the convection. So, convection occur between solid and liquid, like this. Let this is solid, this surface is solid, and here let the surrounding temperature is T infinity, here the temperature is T1, here the temperature is T2, at surface 1 temperature is T1, at surface 2 temperature is T2, and away from this surface the temperature is T infinite. So, temperature drop from T1 to T2 because of the resistance, thermal resistance of this part, and from T2 to T infinite is because of the convective resistance. T1 to T2 drop because of the conductive resistance, and from T2 to T infinite it drops because of the convective resistance, and the law by which it governs is known as Newton's law of cooling. So, heat transfer rate Q dot is equal to H A T S minus T F. T S surface temperature and T F is the fluid temperature, or you many books it will be written as T infinite. So, T S minus T infinite. So, Q dot is rate of heat transfer, T surface temperature, T F fluid temperature, A surface area, and H is convective heat transfer coefficient, and this convection heat transfer is of two types: natural convection, in which no external device is used for the cooling purpose, and another one is artificial or forced convection, artificial, in which we need some fan to increase the cooling rate, because this heat transfer rate depends upon surface area and H. So, if all this parameter remains constant, you can only increase the heat transfer rate with the help of H, and this H is convective heat transfer coefficient, depends upon many things like the surface orientation, its roughness, its nature. So, all these things. So, H is increased in artificial heat transfer rate. So, for the same body the heat transfer rate is improved. And next one is radiation. Now, you all know that in uh, radiation like the energy we are received from the sun, though medium is required, heat transfer rate takes place because of with the help of some electromagnetic waves. So, heat transfer from a hot body without the aid of any intervening medium is known as radiation. So, it is very important, you can feel it, like if engine is working for a long time and you are standing nearby that engine, you feel some heat. So, that heat you are feeling is because of the radiation, and also it is very important because the carbon deposits, because of the combustion of the fuel, the carbon deposits on the engine parts absorb heat due to being black. These carbon deposits act as a black body. So, it absorbs the heat, and many engine parts are polished to reflect out the heat. So, engine structure, material roughness, its polishing is a very important part also in the designing of the engine. Now, we will come on the another topic, different cooling systems. So, different cooling system, I am saying this different cooling system, it is having different types of mechanism. On the basis of the mechanism, you can classify your engine cooling systems. So, various methods are employed to cool automotive engine or stationary engine, and these are, first is air cooling, it is again divided as air jacket cooling, fan or natural air cooling, and forced air cooling. Another one is water cooling, it is further divided as thermosiphon cooling, and second one is pumped or pressurized circulation cooling. Third one, combined air and liquid cooling, very important, this combined air and liquid cooling is the combination of air cooling and water cooling systems. And nowadays we are also using this fourth one, completely sealed cooling. Come to the air cooling system. You all know that here the working substance is air. We are cooling the surface or surface of the cylinder of the engine with the help of air. So, first one is air jacket cooling. We will see one by one. We will discuss all these types one by one. So, air jacket cooling. So, air is made to pass through the small passages formed in the cylinder block and cylinder head. So, the working substance is air here. Second one is network of passages is made all around the cylinder during its casting. So, it is used for small capacity engine, and from the initiation of the casting we take care of it, we make a network for passages for flow of the air, and the air is passed through a single or multi passages either naturally or by artificial means. So, you can pass it by natural way or artificial means, and last one is preferred for moderate cooling. So, I have discussed it that it is required for a small capacity, because in a small capacity low CC engine, low fuel will be low quantity of the fuel will be burnt for a time, and if low fuel quantity burned, then low heat will be generated, and low heat generation results in low temperature rise. So, it can be controlled with the help of air passages or flow of air over the engine components. Second one is some advancement in the air jacket cooling, fin or natural air cooling. So, you know that what are fin? Fins are the extruded part, extruded. In nutshell, Q is equal to H A delta T from Newton's law of cooling. So, for a given condition, if delta T is fixed and H is fixed, so Q dot is only dependent upon the surface area, A is the surface area. So, area, if we improve the area, then heat transfer rate is improved. So, here we use some fin, means extruded part like this. These are some material which is posted over the components of the engine. You all have seen in your bikes this type of design. So, it increases the surface area, so heat transfer rate is improved. Sorry. Last one is forced air cooling. Here we provide a fan blower used for purpose and hence system is known as fan or air cooling. If it is the artificial way and H is improved here, all parameters are fixed. If we improve the velocity of the working fluid, then H is improved. So, H improved, heat transfer rate is improved. So, the air cooling system is that which required air as a medium. When fin, what is fins? These are extruded surface, a greater surface area, greater will be the heat transfer rate, and these fins are having high thermal conductivity materials. Now, the air cooling system, you can see these fins are of this different shapes are available, fins of various triangular, convex, trapezoidal, rectangular or concave. So, depending upon the size of the or structure of the fin, the heat transfer rate calculation you can see that this is the surface temperature, root temperature, let the root temperature or surface temperature is Ts, and this is the tip temperature, let the tip temperature is T2, or you can say the tip temperature as the surrounding temperature. So, you can see this concave parabolic, the temperature reduction rate is very high as compared to the rectangular one. This is the rectangular one, and this concave one is this one. So, this one will be more effective as compared to this one. So, air cooling tends to become less effective when number of cylinders increases in an engine because of reduced surface area around each cylinder. So, when we go for the multi cylinder engine, this no more become more effective. Another category is liquid or water cooling system, liquid or water cooling system. So, the inefficiency of air cooling system can be overcome by the use of this system, because what about the efficiency? Efficiency means if we go for the multi cylinder engine, air cooling system becomes inefficient. So, the inefficiency of air cooling system can be overcome by the use of the system. Heat transfer rate occurs mainly through water in addition to the air, and this heat transfer is the mixed from solid cylinder to water and then heat transfer from water to air. Heat carrying medium is water. Dissipation of heat is done by the circulation water through the water jackets present around the cylinder and passes this hot water through the radiator where air absorbs heat from the water. Water jackets, cooling fan and radiator are the important parts of the cooling systems. So, these are the other parts which you can see in the diagram. This diagram shows the different components of the this water cooling system. This part is called radiator part, this part is called fan, and this is multi cylinder engines. These are the cylinders, cylinder 1, 2, 3 and 4, and this water is circulated all around the cylinder. This is part is thermostat, and here as the vehicle is moving in this direction, vehicle movement and the air will come in this direction. It is forced cooling also, mixture of forced cooling as well as the because fan is here. So, it is a mixture of conduction and forced cooling, and we are using water as the medium. This is the water cooling system design, how this water is jackets are formed. Now, the first type is siphon, thermosiphon water cooling system. So, you can see this system works on the principle that the water, that the hot water being lighter rise up and the cold water being heavier. So, the hot and cold water, so this water circulated all around the cylinder. So, hot water, here the cold water comes here like this, and the hot water goes into this direction, and here the we apply the fan. So, it gets cooled and come out in the downward direction. Now, the water cooling system. So, water cooling system is another type, force circulation. So, in force circulation you can see we uh, apply some pump with the help of pump. This is the water pump, and with the help of this pump water is circulated through the jackets provided in the cylinder 1, 2, 3 and 4. It is surrounded, and water is pumped. This is cold water is pumped out, and the hot water comes up one direction, and this the multiple tubes are there, and radiator tubes are here. It comes down, this is upper tank, this is lower tank, and because of this fan movement and of air also in this direction. So, it gets cool, and the water circulation is with the help of pump. So, this was all about this lecture, and in this lecture we have discussed what is engine cooling system and why we need it in different description of the engine cooling system, air cooling system and water cooling systems. So, thank you so much.